Okay, Chapter 2, Section 4, Piecewise Functions. This is actually a continuation of parallel and perpendicular lines. It's just another part. Piecewise function is a one function that has different function rule for different parts of the domain. Meaning, a domain is just the possible x values that go into a function. And when I say a function, we're talking about something for every input. There's exactly one output. So if I look at the function rule f of x equals negative 2x plus 4 for any values of x greater than or equal to 4, or 6x plus 1 for any values of x that are less than 4. So let's go ahead and let's look at f of 6. If I plug in f of 6, that means the x value is now 6. So which function am I going to use, the top one or the bottom one, in order to get an answer for that? Well, since it is 6 is greater than or equal to 4, that means I'm going to use the top function, and I'm going to plug in 6 for the value x. So I have negative 2 times 6 plus 4, which is negative 12 plus 4. Negative 12 plus 4 is negative 8. So my answer is going to be an ordered pair, 6, negative 8, where the x value is 6 and the y value is negative 8. Now let's do the next one, 4. Which function should I use when the x value is 4? Well, is x greater than or equal to 4, or is x less than 4? Well, it's greater than or equal to 4. So we're going to go ahead and use this top one again. So I have negative 2 times 4 plus 4, negative 8 plus 4 is negative 4. So my next value is going to be, the x value is 4, the y value is negative 4. F of 2, well, which function does it fit? It fits now the bottom function. We're going to use 6x plus 1, and we're going to plug in 2, because 2 is less than 4. So I have 6 equal, or f of 2 equals 6 times 2 plus 1, which is 12 plus 1, which is 13. X value is the input, which is 2. Y value is the output, which is 13, and there's your ordered pair. Let's try another one. Given the following piecewise function, find the following output values for the below input values. So we're going to use the top function for f of x for anything where x is greater than 0, and the bottom for anything where x is less than or equal to 0. So if I have negative 4 for x, I'm going to plug it in there, so I have f of negative 4. Which one am I going to use? Well, I'm going to look at these right here. X negative 4 is not greater than 0, but it is less than or equal to 0. So I'm going to plug in 2 times negative 4 minus 10, gives me negative 8 minus 10, which is negative 18. My ordered pair, this is my x value, this is my y value. I have negative 4, negative 18. If x equals 0, I'm going to use the bottom one again because we have x is less than or equal to 0. I'm going to plug in a 0 for the x value. So I have f of 0 equals 2 times 0 minus 10. 0 minus 10 is negative 10. So my x value is 0. My y value is negative 10. What about 3? Well, since 3 is now greater than 0, we're going to use the top function. So f of 3 equals 3, we're going to plug in our x of 3, so 3 squared plus 3 minus 2 is, do my exponent first, order of operations, so I have 9 plus 3 minus 2 gives me 12 minus 2, which is 10. So my x value is 3, my y value is 10. 3, 10. We'll try one more. This one has 3 different domain values. Notice how I have 3 different parts. Since that's the case, I have to look at and see where the x value fits. So g of negative 3. I'm going to go over here. Where does negative 3 fit? Well, here's a negative 3 in the first one, but in between negative 5 and negative 3, and it's not equal to. So I have to, it can't be the first one because x would be less than negative 3, not equal to negative 3. Here, x is, or negative 3 is less than or equal to x. And if you notice, The reason I'm using this one is because of the equal to sign right there. So let's look at, we're going to be using this one. So g of negative 3 equals 3. Look at my function. It just gives me a 3, and so that's the answer. So my value is negative 3, comma 3. This is my x, my output is my y. So it looks just like that. Don't let that trick you. It's just that simple. Now, g of negative 6, where does that one fit? Well, where is x less than negative 6? As you can see, it doesn't fit anywhere. X is not in between, negative 6 is not in between negative 5 and negative 3. It's not in between negative 3 and 1, and it's not in between 1 and 3. So there is no solution here. There's none. Okay, we don't have a place where this fits, so that means we don't have an answer. It's not 0. It just does not have this particular domain does not have a range. G of 2. Where does that one fit? Well, it's not in between negative 5 and negative 3. It's not in between negative 3 and 1, but it is in between 1 and 3. So that means we're going to use this function. So I have g of 2 equals 2 times, or I'm sorry. Not working. All right, we have, 3 times 2. Plug in 2 for the x, 3 times 2 minus 6, which is 3 times 2 is 6, minus 6 is 0. So 2 is my x value, and 0 is my y value. Now, the last thing you're going to have to do is graph. Okay, so let's go ahead and graph this last function that we just had. Okay, and how do I go about doing that? Well, let's look at it. Let me show both pages here. Okay, well, I know that when x is between negative 5 and negative 3, I have x plus 8 as my function. So I have to figure out, well, where is between negative 5 and 3? Well, let me get a highlighter. So I have negative 5, so 1, 2, 3, 4, 5. In between here and 1, 2, 3 here, the function is going to be x plus 8. So it's going to be a line x plus 8. Well, the line x plus 8, the y-intercept is 8. So let's look at that. The y-intercept would be 8. 1, 2, 3, 4, 5, 6, 7, 8 here. Okay? And the slope is 1. That means it's going up 1 over 1. So if I were to use that line, see if I can use it, it would look like this. Except the only problem is I'm only using that line in between negative 5 and negative 3. So that means I'm going to shorten the line to here. Okay? And here's what you have to remember. Since this is an equal to sign, let me get my pen. Since that is an equal to sign, that means this one over here has to be a closed dot. Okay? Since this is a less than sign, that means this one here has to be an open dot. Okay? Then, between negative 3 and 1, so let's pick our highlighter and get a different one, negative 3 here, and all the way over to 1, anything I put in for x, I'm just going to get an answer 3. So what does that line look like? Well, y equals 3 is a horizontal line at 3. So let's go ahead and do that. 1, 2, 3. So I go from here to here, and I have my horizontal line. Now I have to look at the symbols to decide what's that line going, or where my dot's going to be. Well, I have an equal to here, so that means this one's going to be closed, which makes sense since this one's open. And over here, this one's also going to be closed because we have an equal to sign. Okay. Now I have between 1 and 3. So let's look at where that's at. Highlighter between 1, let me get a different color. Between 1 here, and we have 2, 3 here. The line is going to be 3x minus 6. So if I were to graph that line, 3x minus 6, the entire graph, and then shrink it down between the domain 1, and 3. So let's look at that. 3x minus 6, so negative 6 is my y-intercept. 1, 2, 3, 4, 5, 6. So I'm going to start there. Maybe. 1, 2, 3, 4, 5. Start here. And I'm going to have a slope of 3. So I'm going to go up 3. So we have up 3, 1, 2, 3 over 1. Up 3, 1, 2, 3 over 1. Up 3, 1, 2, 3 over 1. So that's going to be my line right there, except the only problem is you can't have it go past your domain, which is this blue part right here. So I'm going to shrink it down to here. Okay? Then I have to look at my dots. They're both less than. That means I have 2 open dots here. And that's how you graph. Those are a little trickier. You'll get a chance to try that on your homework. If you have questions, I can go over those with you. Go ahead and try your worksheet.